Hello guys, we are from Division B, Group 6 and our topic is working of interrupt. I am Shreya Bambal, roll number 31 and my group members are roll number 30, Omkar Bajpai, roll number 32, Prathamesh Bansode, roll number 33, Atharva Bapat, roll number 34, Pranav Barakte, roll number 35, Tanvi Baraskar. In this presentation, we have tried to include some of the topics which are introduction to interrupt, how does an interrupt works, advantages of the interrupt, challenges of the interrupt, applications of the interrupt, and future of interrupt. Now let's move towards the introduction of the interrupt. Interrupt is an approach to transfer data between memory and input-output devices. Interrupt is basically a technique used in computer system to improve the efficiency of the input-output operations. It is designed to handle input-output devices in a way that minimizes the amount of the time that CPU spends waiting for the input-output operations to complete, while to avoid the excessive use of CPU resources. Traditional input-output methods rely on CPU constantly checking the status of the input-output device to determine when an input-output operation is complete. This is known as polling or busy waiting. This approach can be inefficient because it requires the CPU to use an significant amount of processing power even when there is no input-output activity to perform. This can slow down the system and increase the power consumption. Interrupt input output provides a more efficient approach by using the hardware interrupts to notify the CPU when an input output operation is complete. This allows the CPU to perform other tasks while the input output operation is in progress. The hardware interrupt is a signal sent by the input output device to the CPU when the input output operation is complete. When the CPU receives the interrupt, it stops what it is doing and switches to the special routine called an interrupt handler. The interrupt handler is responsible for handling the interrupt and completing the input output operation. Once the interrupt handler has completed the input-output operation, it returns the control to the CPU, which can then continue executing the previous task. This approach eliminates the need for the CPU to continually check the status of the input-output device and wait for the operation to complete. Instead, the CPU can perform the other tasks, maximizing its efficiency and minimizing its power consumption. The interrupt input output is commonly used in modern computer systems to handle various types of input output devices, including the disk drives, network cards, and input output ports. It provides a more efficient and reliable way to handle input output operations while minimizing the impact on the overall system performance.
So now we are going to see how interrupt IO works. When an IO operation is initiated, the device sends a signal to the CPU requesting access to the system bus. The CPU responds by granting the access and then continues executing other instructions. When the IO operation is complete, the device sends an interrupt signal to the CPU to notify CPU that the data is ready to be processed now. The CPU then stops what it is doing and services the interrupt first, which involves transferring of the data from the device into memory or vice versa. Once the data transfer is complete, the CPU resumes to its previous task and continues the working. As we can see in the flowchart alongside, IO interrupt firstly check the status of the IO module. If there is any error, it returns the error condition. If there is not any error, it is ready to read the word. It reads the word from the IO module. Then IO module goes to CPU. It writes the words in the memory and the process is done. After the execution of this process, it proceeds to the next instruction, and if the process is not complete, it issues the read command to the IO module to do something else. The flow diagram show you how with the help of interrupt IO, the data transfer is carried out between memory and IO. Though it is more efficient than programmed I/O, still it wastes some of the processor's time as the transfer of data from memory to the I/O module or from the I/O module to memory passes through the processor.
So next we will see the advantages of interrupt driven input output. One of the main advantage of interrupt driven input output is that it allows the CPU to perform other tasks while waiting for input output operation to complete. Other advantages are: first advantage is efficiency. Interrupt driven input output allows the system to perform other tasks while waiting for input output operation to complete. This eliminates the need for constant polling. Next advantage is responsiveness. With interrupt driven input output, the system can promptly respond to external events and processing them in a timely manner. By interrupting the CPU when an input output operation is complete or when data is available. Next advantage is simplicity. Interrupt driven input output simplifies programming compared to polling based input output. Rather than continuous checking for data availability, the programmer can set up interrupt handles to handle specific events or interrupts generated by input output devices. Next advantage is scalability. Interrupt driven input output is more scalable in system with multiple input output devices. Each device can have its own interrupt signal, allowing the CPU to efficient handle input output operation. The next advantage is energy efficiency. Interrupt driven input output helps to conserve energy by allowing the CPU to enter low power status when there is no interrupt activity. Overall, interrupt driven input output offers improved efficiency, responsiveness, simplicity, scalability, energy efficiency, and synchronization compared to polling based input output, making it a preferred approach to handle input output operations in many ways. In interrupt driven data transfer, whenever input output is ready for data transfer, it will interrupt the CPU. In the ISR, the CPU will perform the data transfer. This method is better than polling because here CPU does not have to waste time in checking the status of input output device.
Interrupt-driven I/O is a technique used by computer system to manage input and output operation. Instead of continuously pulling devices for data, the system sets up an interrupt to be triggered when the device has a data available or it is ready to accept data. While this approach has a many advantages, it also possesses several challenges. First challenge is overhead. Interrupt-driven I/O required a significant amount of overhead to manage. Each interrupt requires the CPU to stop its current task, save its state, and switch to a new context to handle the interrupt. This process can be a time consuming and can slow down the system, especially when handling a long number of interrupts. Second one is a delay. Interrupt driven IO can introduce delay into the system. When an interrupt occurs, there is a delay before the CPU can handle it. During this delay, the device may continue to send data, resulting in the loss of some data. Third one is a synchronization. Interrupt driven IO can also lead to the synchronization issue. If multiple interrupts occur simultaneously, it can be challenging to ensure that data is handled correctly and that there is no conflicts between different devices or processes. Fourth one is resource management. Interrupt-driven I/O requires careful resource management. For example, too many devices are interrupting the CPU at once, the system may become overload and leading to the system crashes and other issues. Fifth one is a real-time constraint. Real-time system requires timely responses to interrupts. Interrupt-driven I/O can introduce delays that may not acceptable for real-time system, leading to missing deadline and other issues. Overall, while interrupt-driven I/O is a powerful technique for managing I/O operations, it requires careful consideration and management to ensure that it operates efficiently and effectively within the system.
Now we will see about the future of interrupt input output. The future of interrupt input output lies in advancement of computer architecture, handling the input output operations. There are several trends for development that can shape the future of interrupt input output. First is hardware improvement. This could involve the specialized interrupt controller, increased interrupt handling capabilities, and optimization to reduce interrupt overhead and latency. Event-driven input-output. In event-driven input-output can be leveraged technique such as polling and signal-driven input-output more efficiently and reduce the interrupt overruns. Input-output virtualization. Future of input-output handling mechanism may be designed to better support input-output virtualization, providing isolation and performance guarantee efficient sharing of input-output devices among the virtualized environment. Alternative for input output. So emerging technologies such as non-volatile memory, persistent memory, and advanced storage technology may be demand a novel of input output approaches to fulfill their leverages and their capabilities.
Conclusion. An interrupted input output is a process of data transfer in which an external device or a peripheral informs the CPU that it is ready for communication and requests the attention of the CPU. Interrupted input-output refers to a situation in computer programming where an input-output operation is interrupted before it is completed. This can occur for a variety of reasons, such as a signal from the operating system or an error in the hardware. When an input-output operation is interrupted, the program that initiated the operation is suspended and control is passed to the operating system. The operating system then performs any necessary actions such as sending a signal to a program or handling the error before resuming the program. Interrupted input-output can be challenging to handle in programming as it requires careful consideration of how to handle the interruption and resume the operation in a safe and efficient manner. However, it is necessary part of modern computer system and is used extensively in wide range of applications. In conclusion, interrupted input-output is a critical concept in computer programming and is necessary to ensure the proper functioning of many modern computer systems. While it can be challenging to handle, careful programming and attention to detail can help ensure that interrupted input-output is handled safely and efficiently.
Thank you.